Hello and good afternoon, and welcome to this video tutorial on EIGRP stub routing. This is going to build on lab 2.2 or 2-2, and what we're going to be talking about here is some behavior that you'll see with EIGRP where it will take a static route and it'll actually originate that route as a connected route to its EIGRP peers. And so lab 2-2 gives us a great opportunity to see that behavior in action, because it actually walks us right into that scenario during step 2 where we're configuring EIGRP. So as you can see here, our topology over here to the right is still intact, and I've actually configured, if you're following along in the 2-2 lab, I've actually configured step A or step 2A. So now we're down to the summary configuration. So I'm going to go ahead and on router 2, we're going to go into privilege exec mode, interface serial 000. I'm going to say IP summary address EIGRP 100, and it's 192.168.0.0 and 255.255.248.0 is going to be our summary. So we're not really interested in the summaries, but we want to make sure we have it in there, because this is right up to the point where we're going to actually see the behavior that we would, we would expect to see. So if I'm in privilege exec and I say show IP route, let's take a look at our routing table right now. As you can see in the routing table, we have 3 EIGRP originated routes. We have the route for the directly connected interface 10330, which is the simulated LAN segment behind router 2. We've got one for 10440, which is the simulated, the transit network between router 2 and router 3. And then we have the summary, which we just created here for the loopback addresses hanging off of router 2. And so what is it that we want to take a look at? And this, again, I want to make sure that I'm clear on this, that this is not an EIGRP bug, and this is not some sort of a stupid router trick, right? They typically used to call, during the CCIE exam, certain things that you had to do, like stupid router tricks, where they would try to make you do something, you know, ridiculous, like maybe put a question mark in a file name or something like that, where you would have to put the control characters to precede it, things like that. And this is not that. This is actually EIGRP doing exactly what EIGRP has always done and what it's supposed to do. And it's actually, and you'll see, it's in the rib. When we take a look at the rib and the fib, it's iOS that's actually flipping a bit that's making EIGRP behave the way that it does. So let's take a look now. So step 2C says configure a static route on R2 to point to R3's LAN. So let me go ahead and get to global config mode here. And we're just going to say IP route 10.1.5.0, and this is /24. So there's my statement. Now, in the lab, it's interesting. They ask you to use, or they show you to use the next hop IP address. However, if you think back to the CCNA studies, right, I mean, that pretty much is counterintuitive to everything that we've ever done. So if I'm creating the static route here and I'm pointing it to this network here behind the R3 router, the R3 LAN, this is a point-to-point link. So if I'm creating a static route to point to that router, what have we always learned? Well, we've always learned that all you need to do is specify the outbound interface as the next hop. Because it's point-to-point, by giving it the interface, there's no question it's simply going to go to the other end of the link, because there's nowhere else the traffic can go, right? So by giving it the outbound interface is absolutely fine. But let's see how EIGRP behaves when I say serial 010. So if I step back over here to router 1, let's take a look at the routing table now. So I say show IP route, and what do we see that's different? Well, right away, we notice that for whatever reason, we are now originating the LAN segment that sits behind router 3 into EIGRP. And this is interesting, right? So 10.1.5.0 that's actually this network here behind router 3. However, router 3 is not running EIGRP. In fact, we've got a default route and a static route on router 3, and that is it. It's clearly, as you can tell from the drawing here, it's clearly outside of the Autonomous System 100. And again, it is not running EIGRP, so it's not redistributing this in any fashion. And in fact, take a look here. Router 1 is seeing this as an internal EIGRP route with a administrative distance of 90. And then we have our EIGRP metric, right? And this is also known as the feasible distance. And the feasible distance is the lowest metric value to get to this network. And so it's interesting. Let's go ahead and do it the way the lab wanted us to set it up. So if I were to say IP route 10.1.5.0, it's a /24, and then say 10.4.4.2, because that's the next hop IP address. That's the IP address on the serial 010 interface on router 3. So now we see we have the next hop IP, not the interface. Let's take a look and see if the routing table looks any different. And it certainly does. Now, for what this lab is asking us to do, you have to use the next hop IP, because if you don't, you're going to run into the situation that we just previously ran into, which is where we end up with an EIGRP route showing up being originated from router 2, representing the LAN segment that sits out behind router 3. Now, this is very curious behavior, right? And it may kind of come as a surprise if you're working in a network and you've got point-to-point links and you're using the outbound interface as the next hop in a static route. You need to be careful and understand the behavior of EIGRP and how it's going to react. And so here are the two criteria that have to be met, and they both need to be met in order for what we saw where we had the outgoing interface as our next hop. Both criteria need to be met in order to get the route to show up here in the routing table. And so the first criteria is that you have a static route and that route is referencing an outgoing interface. So that's criteria number 1. We have a static route, and the static route is referencing an outgoing interface for its next hop. The second criteria, which has to be met in addition to the first criteria, is that it'll only happen if the destination network is included or would fall within the address range of a network statement. So let's take a look back here on router 2. If I say do show run section EIGRP, right, do we have a network statement here into which this static route subnet would fall into? So again, I'm creating the static route, saying my route to get to the 10.1.5.0. So if you have an EIGRP network statement that the destination network that you have defined in your static route, if that falls within the address range of your network statement and you are using the outbound interface to tell your router how to get to that destination network, EIGRP is going to auto-magically, and again, it's not EIGRP that's doing anything weird or tricky, it's going to do what it always does. It's going to go ahead, see that as a connected route, and originate that route. And so let's take a look here as to why it's doing that. So if I were to say do show IPsef 10.1.5.0/24. So what do we have here? So we have, in the Ceph table is the forwarding table, right? And it gives me the IP to the interface, that gives me the IP to interface mapping, the next hop IP and the interface out which I'm going to go to get there. So now this is a next hop with the next hop address, and the resolution in the fib has already taken place. So let's change that, actually let's change that route statement. Let's change it from a static route that refers to the next hop interface, and we're going to change it to a static route that points to the outgoing interface. So now let's run that do show IPsef on the 10150/24 again. And this is why you say that EIGRP is not doing anything out of the ordinary. It's actually iOS, right? It's the Cisco iOS, and it's the way the rib and the fib see this when we enter the static route with the outgoing interface of serial 010. So where we use the IP, it says, oh, next hop IP, and it gives us that layer 2 to layer 3 resolution, right? However, when we reference the outbound interface, it says attached. So it sees that network, the 10150, as being directly connected or attached to serial 010. So this is normal EIGRP behavior, right? Because aren't we seeing the network on router 1 here? Are we seeing the 10.4.4.0/30? Well, we have an interface here that's directly connected. So if I were to say do show IPsef 10.4.4.0/30, how does it represent that route? And you're right, if you guessed that it was going to represent it the exact same way, it does. It's directly attached. It's connected. And so this is what happens with EIGRP, because iOS is actually flipping a bit, right? And when you configure with iOS, when you configure a static route and the next hop is a local interface, and now this even includes the null 0 interface, what'll happen is Cisco iOS sets a bit on that specific route that identifies it as what's commonly referred to as a pseudo-connected route. And by virtue of the fact that it's pseudo-connected, it means that in order for hosts to reach it within that subnet, you know, they would have to be, it's a requirement they would have to ARP to get to it, right? Because again, all I know is the outgoing interface, and again, that bit has been flipped. So since the connected bit gets set by iOS, EIGRP is going to do what it's normally meant to do. It's going to grab that subnet, right, that network, if and only if we have a network statement that that destination subnet falls into, and we do in this case, then it's going to grab it up and it's going to advertise it and originate it out as an internal EIGRP route, like we have right here. Now, again, this behavior commonly throws new learners, and it definitely threw me a loop when I saw it. I actually was fortunate enough to have an opportunity to speak with Donnie Savage, and for those of you that don't know who Donnie Savage is, he is sort of the Uber brain trust for EIGRP. Donnie's been working with EIGRP at Cisco for probably 15 to 20 years, and he has actually written and rewritten most of the code, and so he knows all of the internals. And it was interesting in our conversation, he indicated that it's not EIGRP that's doing anything strange. It's doing exactly what it's supposed to do. Again, it's the iOS that flips that bit, right? Sets the bit on the route that says this is a connected route. And therefore, EIGRP does what it's supposed to do when a network statement includes that address range. It originates a route. So how can we, if we don't want this behavior, what could we do? Well, we already saw that what we could do is we could go ahead and set the static route and change it so that it points to the next hop IP. That's certainly one way. And again, the other way, and we've already kind of mentioned this, is if I go into EIGRP, I could say no network, and this will tear down our adjacency, but that's okay. We're going to build it back up. I could be a little more specific because that's a pretty large range of addresses there, the 10.000/8, right? So I'm including quite a few things. If I like sticking with my static routes and I like to use the outgoing interface, right, and in a point-to-point scenario, maybe I want to be a little more specific with my network statement. So what could I say? Let's do the two networks that were already originated. I could say network 10.4.4.0, 0.0.0.3, and I could say network 10.2.2.0, 0.0.0.3. This is going to bring our adjacency back. And then let's originate the simulated loopback 10.3.3.0, and this is a /24, right? So now let's go back. We're still using the same construct, right? I'm using the outbound interface here. However, we've changed, and let's take a look, do show run section EIGRP. Let's see what that looks like right now. So as you can see, we've got far more network statements here, but they're definitely more specific, and we don't have anything that includes 10.1.5.0. So now let's see, show IP route, what the router 1 routing table looks like. And as we anticipated, since we don't have a network statement that includes the range of the address of the destination network in that static route, in our EIGRP config, EIGRP is not going to originate a route for that network. Now, what if I were to say network 10.1.5.0, right? So now I do have, as you can see here, now both conditions are met. I have a static route to that network that references the outgoing interface as the next hop. Therefore, iOS is going to see that route as being directly connected, right, attached to serial 010, and the network statement matches that destination network. So with the two conditions met, what's the routing table look like now? You're absolutely right. We get that route added back in. And it was interesting in the lab that they don't make mention at all of this behavior, yet they show you that they want you to use the next hop IP address. And again, interesting, because after all of this time, throughout all of your CCNA studies, what were you always taught and told in the examples were, in a point-to-point network, use the outbound interface because there's only one place for the traffic to go. Now, there's nothing wrong with using the next hop IP. You can certainly do that. In fact, let's take a look at the last possible way to represent that static route. So I'll say do show run include route. So we're going to get rid of this static route, and I'm going to do a fully qualified static route. And let's see how iOS reports that back. We'll see what the fib shows for that. So if I say IP route 10.1.5.0, 255.255.255.0, and I'm actually going to say serial 010, and I'm going to put the next hop IP in there. So now I've fully qualified that next hop by giving it the mapping for the layer 2, which is the outbound interface, and the layer 3, which is the next hop IP. What do you think? Is it going to show up here or not? And if you're thinking it's not, you're correct. And the reason that it wouldn't is because it's not going to say it's directly attached anymore. It's going to tell us that it actually has done the resolution, and we'll see that when we run the show IP ceph command. So here we confirm router 1 does not have the route. So fully qualifying it, it does not work. However, when I say do show IP ceph, let's see what it looks like, what ceph is going to report back to us, and there you go. It doesn't show attached, it shows next hop. And here is our layer 3 to layer 2 mapping, right? So I'm trying to get to the 10442, and it's been worked out that that's going to be out the serial 010 interface. So it's not directly connected. iOS is not flipping a bit when we fully qualify it to say that is a directly it's directly connected, right? And that it's pseudo connected, directly connected. iOS doesn't think that. iOS says no, it's fully qualified, and there's my next hop. And the next hop is the same thing it showed when we only used the IP address. So if we pull this off and say no, and then I say IP route 10.1.5.0, and I say 10.4.4.2, what is it? What's the Ceph table going to show me again? Again, next hop, and you can see the fib, right, is going to report back that the next hop, and it does that layer 3 to layer 2 resolution for us. Therefore, it's not simply just directly connected, it's fully qualified, and that is why it does not originate the route over here. And so one last piece of output to look at, which is very helpful, is the show IP EIGRP topo, the topology for 10.1.5.0/24. And you can see we have no entry in the EIGRP table right now. Because remember, it's not originating it as a route. Both criteria are not met because my my static route is not pointing to the outbound interface right now. It's pointing to the next hop, which does that resolution, the fib or the Ceph table, does the resolution, gives me the outgoing interface for the next hop IP. Therefore, it's not, iOS doesn't say, oh, it's just directly connected. It's actually doing what iOS is supposed to do, and that is doing that layer 3 to layer 2 resolution. So I know my next hop IP, and now I know my outbound interface. So it is not attached. So let's fix that. We're going to say no. We're going to, actually, we don't want serial 000. I want to get the whole route statement in there. So we'll copy and paste that, and let's come back and say IP route 10.1.5.0. serial 010, and now let's take a look at our topology table. So as you can see, the EIGRP topology table is going to show us a lot more information here, and there's two very key pieces of information. The first is right here. So where are we learning about this network from? And so it shows up and it says from redistribute static, right? So we've got a static address that EIGRP is saying this is a redistributed static. However, the route is internal. And that's why on router 1, when we say show IP route, the administrative distance doesn't come in as 170, which is the default for a redistributed EIGRP route. It's coming in as an internal route. Because again, that connected bit gets set on the route. So EIGRP is smart enough to see that it's coming from a static statement, right? However, it's an internal route. And as you can also see, we've got our K values here. There's K1 and K3, bandwidth and delay. And so, again, this is actually what's happening with iOS, and this is the EIGRP topology table here with that route. And you can see it lists out the feasible distance, right, or the metric that it has. And so if you see this behavior, that is exactly why it will happen. Is, again, just a recap, if you're using EIGRP and you have a network statement that's pretty wide open and you go to create a static route to a network, and that network for whatever reason falls within the IP address range of your network statement, and your static route is referencing the outgoing interface and not the next hop IP, EIGRP is going to see it as a connected network, and it's going to originate a route in EIGRP as an internal EIGRP route with an administrative distance of 90, and then you'll have your feasible distance, or your EIGRP metric value will be whatever it works out to be. And so again, this is a great way to check to see, how am I learning, right? Where is it coming from? And then what kind of a route is it? All right, so that pretty much wraps up this video tutorial on why you would see a static route all of a sudden sort of get converted into an EIGRP route that shows up in your EIGRP routing table, and that is why it happens. And again, not an undocumented feature, not a bug of any kind. This is, again, EIGRP doing exactly what it's supposed to do when a network statement includes what it is being told by iOS is a directly connected network, right? With that connected bit being set on that destination subnet, EIGRP, just like it did for interface serial 010 and the 10.440/30 network, it's going to originate a route for that, and it's going to advertise that route to its peers. And in our case, it was in AS100. All right, well, I hope you've enjoyed this video. I hope you understand a little bit more about one of the odd behaviors that you'll see that you might not at first blush sort of understand. Well, hey, why is that route showing up? And I certainly didn't myself. And again, it's good to know sort of how things will behave. And like I said, you're following best practices using the outbound interface on a point-to-point link, just as you've been taught all throughout CCNA studies. And then you end up with sort of a route that pops up and you're not quite sure why it's there or how it got originated. All right, thanks for watching and enjoy the rest of your weekend.